Hi. What you just witnessed right there was a rotation. And what are rotations in 3D space without quaternions? But first, the most important question. What is a quaternion? Quaternions are a four-dimensional form of rotation within 3D space, which rivals that of two types of vector rotations, these being Euler angles and directional vectors. In short, Euler angles are vectors used for rotation, whereas directional vectors are used for forces. Quaternions have four values: x, y, z, and w. The first three values, x through z, or the vector part of the quaternion, determine the direction of the axis at which the w value, or this gray part here, of the quaternion will rotate around. Think of it like a rotation of a rotation. The vector part of the quaternion is known as the quaternion's axis, right here. Our w value, or the gray ring, can then be represented as the angle of our quaternion. Now, I want to show you some of the less intuitive quaternion circuits so that you can get a full understanding of quaternions. Starting with, quaternion create angle axis is similar to quaternion create. Instead of requiring a w value for the specified rotation, you instead use a formatted axis and input the amount of degrees that it will rotate around said axis. And you can see the direction here, and I create my angle axis using this same vector, and each frame I add 5 to my variable that will then correspond to the angle of my angle axis, and I will then set the rotation of my object. So you should see this rotating continuously around the axis I've specified. Quaternion create Euler angles. This chip is primarily used to convert Euler angles to quaternions. This does not work with directional vectors. Quaternion Euler angles works in the opposite way, as in it converts quaternions into Euler angles. Quaternion create look is different from the last two chips in that it creates a quaternion from a directional vector. Use your desired direction as the forward input and make your up input 0, 1, 0. This defines the default upwards orientation. In this example, you can see quaternion create Euler angles wired to quaternion Euler angles, and with our input 1, 0.25, and 0.5, running it through create Euler angles will create our quaternion, and then we can use our quaternion input on quaternion Euler angles to see that they are the exact same. Quaternion create look, we have our specified direction. This is a directional vector with direction and magnitude. Our upwards value is defined as 0, 1, 0, and from that we have a directional vector that will point in the specified direction. Our last two chips are quaternion create from to and quaternion rotate towards. Quaternion create from to generates a rotational quaternion from a starting vector to a target vector and is not used for interpolation. Quaternion rotate towards can be used for interpolation. It takes in two quaternion inputs, and the max degrees delta is the amount of degrees that your object will rotate per frame. So if we set the rotation here, we can see that these become equal. Now that you have a general understanding of quaternions, as well as the majority of quaternion chips, hopefully they don't seem as hard to understand as before. Thank you for watching. Oh shit. I'm just going into the void.